Okay, this is a set of visuals that animate the basic functions, a sample of the basic functions of the data management system. We start with the basic mapping tool that allows for the development of the project boundaries. And you can upload shapefiles, you can upload coordinates, or you can draw your own boundaries. The boundaries can be much more detailed than this. This is just so that it can be developed quickly for an example. We have a three-layered hierarchical structure. The highest level is the project boundary. That's what's shown here. It is developed with a backend that has a interactive relational database. So this develops a tool that has simple editing functions, and in doing so is mapping out for a project area or whatever your sample area might be for deploying inventory plots at the large level. So within that you can drop markers by hand, or there's a tool that will place the markers statistically in particular places, and you can develop rectangular, circle plots for fixed radius plots of any dimension or size. This shows a radius of 20 meters, a kind of standard dimension, and establish your plots. Or these can be developed by uploading the plot files from the inventory that was taken in the field. This next animation shows how to subdivide the overall project into strata. We call them parcels. They can be parcels as strata of different vegetation or forest type, or they can be administrative parcels. It's a hierarchical system. You can change the name, you put in all the information, and then you associate plots with each of the parcel. So now plot 10 is associated with forest management block 2. And when the data come in from the field, they'll be associated with that. In this case, there are no parcels assigned, but you can make the assignment through the relational database. Update it, and now it's setting up the sample frame structure by stratified random sampling. The data would then come in from the field and then be associated with the plots for that strata. From there we move to a measurement piece that allows for the organization of all the inventory data, including information, memos, anything you want. There's a tremendous amount of content management that goes behind this this tool. You can see that there's information and guidelines from international sources, and as well as your memos and reports from your national agencies. It has a ability to record tier 1, 2, or 3. We focus on tier 3 data, and this allows you to upload your sheets of data from the field, which can be a spreadsheet, or it's actually linked into a handheld device as well. So you can upload the plot biomass data that you've collected in the field. You make some assignments like root to shoot ratio. You define the allometric equation out of our library that you need to use, and then you just go ahead and upload the data. This is the tree by tree plot inventory data, and this is just showing an example of how you walk through it. You upload the file, and then it says yes, you've done it, and then it gives you a summary page of what's in your plot data. So this shows a simple inventory of individual trees measured by dBH. A lot of information can go in here that's not in this particular example. So it's open-ended as the kind of information you can put in there. We do have a library of allometric equations and the ability to use the IPCC default equations or add your own, as it's showing here, allometric equation. So a few simple rules about how you define your equation, the model for the equation or form of the equation, whether it's volumetric or biomass based, and whether you want to share this with anybody else that's using the system. And then this is the lexicon that's used, and the equation format, simple format. This format will accommodate almost any kind of form of a allometric equation. The user specifies it, and then you can upload your own specific, location-specific allometric equation. Once all the data have been entered, then you can summarize your carbon stocks by parcel, individual parcel, the Forest Management Block 2 parcel. You can provide a carbon summary for the whole area. And there's a calculator that gives you the uncertainty on biomass. We also have the ability to load in data for soil, litter, and deadwood. But we're really focused on above and below ground inventory data with this tool. But one of the essential features of the tool is to develop the sample frame. And this starts with a specification of the accuracy and precision that you desire. You also need to have, according to IPCC methods, some general estimation of the variance associated with the sample you're making. This can be done with a pre-sample or taken from the literature, and the plot size. And then by putting the pre-sampled information in, it'll calculate by strata using standard methods the number of plots that you need in order to meet your sample requirement. In this case it was 7 for this one strata, Forest Management Block 2. And then by clicking on the mapping tool, you can ask it to generate a map of where your plots should be based on random stratified sampling or systematic sampling. You can click on that and it gives you the UTM coordinates, so you can use this to send information to field teams so they can deploy to the right places in the field. There's a number of associated literature with the tool, and you can upload your own. There's a way to work with allometric equations to do updates, as mentioned earlier. Decide how to share them, how to add your own allometric equations. So a number of associated management tools come along with this that allow you to manage your project data, keep it organized, share it, or keep it proprietary. This shows you how to manage individual plot data. If you really want to, it should have been a fixed radius plot. You can fix it, or you can set it up however you want so that field teams use it. Establish your root to shoot ratios, and manage all your plots in that way.